Kublai phi baro kiba pay kini ka video hibya subhai fi share ni ka channel ka tech tutor Meghalaya balapan mi da ka SCSTE. Bekerteng janga kalong iba pediang hun kongwir but hakani ka porpat and bataya phi shapang ka electric field due to a hollow sphere. Te hakani ka topic ngan discuss earthly ka position. Mabakadi ka hollow sphere fi sung firm kadi ka sphere ka bathli shapo. They can discuss earthly position ka way they outside, alright, at a point outside the sphere, but the second position part can they at a point inside the sphere. Therefore, case 1, can they at any point outside the sphere. Consider a hollow sphere of radius capital R and let P be any point outside the sphere at a distance R from its center. Tingin niya drawing in your diagram. Timinta, hani fi ngadan gani ka sphere, alright, this is a hollow sphere. Hapadeng dani area, okay? Tiki charges baro khatkidan on the surface of the sphere kumni, alright? Timinta, I've considered this sphere, alright, the radius, the capital R, okay? Timinta, ngan shimaway point P outside the sphere, alright, this is my point P, which is at a distance, small r, alright, from the center of the sphere. So this distance from the center, let me name the center O, alright, is small r. Okay? Now due to these charges on the surface of the sphere, alright, there is an electric field. But the direction of the electric field, since ki positive charge, kilong kumno directed away. Alright? So due to these charges, the direction of the electric field along away from the charges. So that is the direction of E. Alright? The direction of the electric field ro ni ong kalong radial. Radial kamot kumno kalong along the radius of the sphere. Kamot pa shubu tanga shu extend, alright? You near u vector arrow uba represent the electric field, alright? And draw towards the center, alright? Kalong along the radius of this sphere. Then now, to find the electric field at point P, alright? Due to this charged hollow sphere. Once again, ngan perenkam nak A, ngan perenkam nak Gauss law. Namar ka charge hollow sphere again, kadeka surface continuous charge distribution. Okay? Te ngan use ka Gauss law, and ben perenkam ka Gauss law ngan haban lekum no, ngan haban dan ka Gaussian surface. Alright. Kini ki charge hani ka por kidan on the surface, kidan halor jang ka sphere, not inside the sphere. Tikidan halor jung ka sphere nakataka daw kimdan re kano ka surface ka basaraw ni kini charges. Nataka daw man haban draw again ka Gaussian surface, and ka Gaussian surface hakani ka por nan pen kam ka spherical Gaussian surface, and this spherical Gaussian surface kadiban pass through that point P. Okay. Tingin niya draw kan? Alright. Tika niya Gaussian surface hani nga draw nga represent kini ki dotted lines. Alright. And this Gaussian surface it passes through point P, and it encloses kini ki charges, alright, kibadan gani ka hollow sphere. Alright, timinta tingin ala man pren kami ka Gauss law. So we have constructed a spherical Gaussian surface concentric with the given sphere such that it passes through point P. Concentric kumut ayu. Concentric kumut they share the same center. Alright, kumba fi hang ni, alright. Kini ka Gaussian surface nga drawn in such a way that it has the same center O, alright, the same center as this hollow sphere. Okay, and one more thing to note down, kani ka Gaussian surface, alright, radius jong Gaussian surface kandi ka no, kande small letter r. I have drawn this Gaussian surface with the radius small letter r having the same center as my hollow sphere. Okay, let Q be the total charge on the hollow sphere. So this is the total charge on the hollow sphere. Kabumut ba the Gaussian surface, alright, enclose the total charge Q hapo. Okay, so now from Gauss law, what do we have? Again, surface integration of E dot ds, alright, is equal to 1 by epsilon naught times the charge enclosed by Gaussian surface. Te hang ni, this becomes E dot ds is equal to 1 by epsilon times charge Q. Te ini area ds hani pangan consider at this point, alright, here around point P. This is my area ds. Okay. the ds once again in terms of vector there is again a normal vector. The vector along perpendicular to the surface. So it will point in this direction. This is my ds vector. Alright? So this is my ds vector and this is my electric field. So if you look at the electric field also, due to this charge, the electric field can point away here at this point also. Alright, this is the electric field at point P. Can point shate sha bar he. So as you can see, ds and E, they are in the same direction. So the angle between them is 0 degree. Right? Therefore, this formula reduces to E ds cos of 0 degree equal Q by epsilon naught. And what is cos of 0 degree? It is 1. So once again, this becomes surface integration E ds equal Q by epsilon naught. And what is the integration of the total surface of the surface kabangi dongi? What is the shape of surface bangi yo kadai of the sphere? And what is the formula for surface area of a sphere? And what is the surface area of a sphere? It is 4 pi r square, alright, equal Q by epsilon naught. So hangni E is equal to Q divided by 4 pi r square epsilon naught. So this is the formula for electric field due to a hollow sphere at any point outside. Okay, this is electric field at any point outside, alright, the hollow sphere. Okay, it's at any point outside the hollow sphere. Now let's do for at any point inside the hollow sphere. And consider a point, alright, let's say a point Q. This point Q is inside the hollow sphere. Okay, alright, so I've considered this point Q and let this Q be at a distance, alright, R1 from the center of the sphere. Okay, so once again, to find the electric field, I have to use Gauss law, and in order to use Gauss law, I have to construct a Gaussian surface, alright? And habang sinay ka Gaussian surface, kaban pass through yung uni point Q. Then, ang draw man ta ka Gaussian surface, kaban pass yung uni point Q, hangni. Alright, so that is my Gaussian surface. Okay, the Gaussian surface, kalong concentric, once again, it has the same center as the hollow sphere, alright? And it has the radius R1. Fine. Now, look very carefully. What is the total charge enclosed by the Gaussian surface? Hato don charge na enclosed unika Gaussian surface kabarit hanye? Where are all my charges right now? My charges are here outside M on the hollow sphere. Shapo limdani A. Hollow kamat mdani A. Shapo mdani A re kabamut kaniga Gaussian surface. How much charge does it enclose? It encloses 0 charge. Okay, so therefore Q is equal to 0. So charge enclosed by Gaussian surface is equal to 0. Okay, and from Gauss law we know that surface integral E dot ds is equal to 1 by epsilon naught times the charge enclosed by Gaussian surface. So this becomes surface integration E dot ds equal 1 by epsilon naught times 0. Alright, kabamut surface integral of E dot ds is equal to 0. If I remove the dot product, if I remove the dot product, the surface integral along E ds cos again kade 0 degree, alright, because of the direction of electric field, but ds ka area vector kade same directions, therefore 0 degree equal 0. Kabamut surface integration E ds is equal to 0, or E surface integration of ds is equal to 0. And what is the surface kabang integrate iminta? Once again, it is of the sphere of radius r1. Alright, so it becomes E into 4 pi r1 square is equal to 0. Or in another case, we only that E is equal to 0. Namadang ra ya uni u 4 pi r1 square shani the divide row, the value can be 0. Therefore, the electric field inside a hollow sphere, alright, a hollow sphere is 0. That means there is no electric field inside a hollow sphere. Then jetzt kämen vielleicht noch die derivation yang matuka electric field due to a hollow sphere for both cases. Dengan saya sampai fi hakawai pada video. Kublai syukun.